Hello everyone. In today's session of CCNA series, we will discuss about QoS, also known as quality of service. It refers to the ability of a network to provide better service to selected network traffic while it flows through a network. It defines action a device can apply to a packet between the time it enters the device until it exits the device. These actions are referred to as PHBs or per hop behaviors. PHB defines the behavior or treatment the packet receives at each hop in a network. So R1, R2 and R3 are considered as different hops. Uh, PHB define the behavior or treatment that packet receives at each hop on your network. Let's take an analogy of a traffic. Imagine you are in a traffic jam on a highway. Some cars or I can say ambulances or fire trucks need to get through the traffic quickly because they are carrying people who are there to help or who need urgent help. So in this situation, what traffic police might do is it prioritize this vehicle so that they get a clear path to reach the destination quickly. Similarly, in a network, different types of traffic will exist, okay, like voice traffic, email traffic, videos or online gaming. So these are like vehicles on the highway. So QoS is like your traffic police, okay, which will help you to prioritize important data or important packet like video calls or online meetings so that they can get through the network quickly and without any delay. This QoS ensures that critical tasks are completed smoothly even when the network is busy. Cisco offers a variety of QoS tools on their network devices. These tools allow you the means to manage four different characteristics of network, starting with bandwidth, delay, jitter, and loss. Let's go ahead and look into each of these characteristics briefly. Bandwidth. Bandwidth refers to the maximum data transfer of a link. It is typically measured in bits per second, like Mbps, Gbps. It determines the capacity or how much data can be transmitted over the link per second. Next, we have delay. Delay is also known as latency. It is the time it takes for a packet or a data to travel from the source to the destination across a network. You can describe delay as one-way delay or round-trip delay. One-way delay, as the name suggests, it measures the time it takes for a packet of data to travel from the source to the destination without considering the time it takes for the acknowledgement to travel back. Then round trip delay measures the total time it takes for a packet of data to travel from the source to the destination and back to the source. Then we have jitter. Jitter is the variation in packet delay within a network. So jitter refers to the variation in one-way delay between consecutive packets sent by the same application. For example, if you see here, the packets are having the same window, so there is no delay. I mean, or they have same delay. But after R2, if you see, uh, packet is, if you see the purple packet and the red packet, there is a delay in between. That is called jitter. For example, imagine an application which is sending few hundred packets to one host. The first packet one-way delay is 300 millisecond. The next packet one-way delay is 300 millisecond again. There is no jitter in between first and second. The third packet also doesn't have any delay. So in that case, there is no jitter as I shown you after R1. However, if instead the first packet has one-way delay of 300 millisecond, after R2, if you see green and purple, if they have a 300 millisecond, and the next packet between red and purple, if you see they have a higher delay, you can say for example 350 millisecond. So between second and third packet, that is the difference is called jitter. So the next characteristic is loss. Packet loss occurs when packet traveling across a network fail to reach the destination. If the sender for some application sends 100 packets and only 98 arrive at the destination, so the application flow experience 2% loss. If you see after R3, if a packet drops, you will receive out of 3 2 packets. This is called loss. And this can happen due to network congestion, hardware failures, or error in transmission. This can degrade the performance of an application, especially these sensitive data such as real-time audio or video streams. Now, now we know 4 different characteristics and what they do and why they are required. So different types of traffic have various QoS requirement based on their characteristic and importance. So with QoS, a network engineer sets about to prefer one type of traffic over another in regard to bandwidth delay, jitter, and loss. So some traffic have different QoS need than the others. Let's look at QoS need for different types of traffic, starting with real-time traffic, such as VoIP or video conferencing. So QoS need for these type of traffic is low latency, minimal jitter, and low packet loss. And actually, the real-time traffic requires immediate delivery to maintain quality. So any delay, jitter, or packet loss can significantly impact the user experience. You might have seen like if there is a congestion in the network, your voice packet might uh, uh, get better QoS, or you can say priority, so that your voice doesn't get drops. The next type of traffic is transactional traffic, such as database transaction, financial transaction. And QoS need for such type of traffic is it should be reliable and timely delivery of data. Transactional traffic requires data integrity and consistency. It needs to be delivered reliably and within an acceptable time frame to ensure the transactions are completed successfully. Another type of traffic is interactive traffic, such as web browsing or online gaming. The QoS need for this traffic is low latency and moderate jitter. Interactive traffic requires timely response to user inputs, while it may tolerate some delay. And excessive latency can lead to poor user experience. Like when you're playing game and if there is any delay, so your experience will not be good. But you can manage that little bit compared to voice. Another type of traffic is bulk traffic. For example, file transfers. The QoS need is uh, it requires, it is looking for high throughput. So bulk traffic involves transferring large amount of data. While it may not be as sensitive to delay or jitter, but it requires sufficient bandwidth to ensure timely completion of transfers. Another type of traffic is background traffic, such as software update or backup of devices. The QoS need for such type of traffic is low priority, minimal impact on other traffic. Background traffic is typically non-urgent and can tolerate delays because it should not interfere with the performance of other or more time-sensitive traffic types. So by understanding those QoS needs, network administrator can prioritize and manage different type of traffic to ensure optimal performance and quality of service across the network. So far we have discussed about why we need QoS and different type of traffic that have different QoS requirement. Much like positioning of ACLs, QoS tools sit in the path that packet takes when being forwarded through a router or switch. Like access list, QoS tools are enabled on an interface and enabled for a direction packet entering the interface, that is before the forwarding decision, or for packet exiting the interface after the forwarding decision. So tools that we can use to implement QoS are classification and marking, queuing for congestion management, or shaping and policing, and congestion avoidance. So in my next session, uh, I will start discussing about different tools in details. I hope this was informative for you. Thank you for watching.